All right, so now we're going to think about our rational zero theorem. So what we're really thinking about here is that if I have some polynomial with a leading coefficient and a constant, then any of my roots are going to be rational numbers. Any rational roots would have to be a factor of my constant divided by a factor of my leading coefficient. So if I think about this, what that really means, like if we look at this example, is if I was going to figure out factors to multiply this out, there's going to be at most 3 linear factors. One of them would have to start with 2, and these 3 values together would have to multiply to make 9. So maybe I could have 3 and then -1, -3 as a possibility. Well, if I look at this, that means that I would have x values of -3/2, +1, +3. So factors of 9 divided by factors of 2. So all possible rational zeros, so this is an example of how it could factor. I don't know if that's correct or not. The rational zeros would end up being ±9/2, ±9/1, ±3/2, ±3/1, and then ±1/2, ±1/1. So these are all the different possibilities that I could have based on constant divided by leading coefficient. So let's look at example 9 and how we would use this. So based on this polynomial, I know that my potential rational roots would be either ±2/6, ±2/2, oh, I skipped one, sorry. First, I'm thinking about descending order of this, ±2/3, ±2/2, ±2/1. All right, then I also have changing around the other factor of 2 is going to be 1, so ±1/6, ±1/3. I have that here already, so I'm not going to list that again. ±1/2, ±1/1, and I already have 1/1 here, so I'm not going to list that again. So these are all my possibilities. Now, if it's going to be a factor, then I'll be able to plug it in and have a value of 0. So I'm going to test the easiest one first, f of 1. So 6 + 11 - 5 definitely does not equal 0. Let's try f of -1. That would give me -6 + 11. If I had -1, that would turn into +3 - 2. That definitely does not equal 0. It looks like I need some smaller values, so next I'm going to try either a half or a third. So I'm going to go with a half first, and I'm going to go with -1/2 to try and shrink the numbers down, because this 11 is pretty high here. So -1/2 I'm going to try, so that's going to give me -6/8, and then I would have 11/4 minus 3/2 minus -3/2, so plus, and then -2. So this is going to be -3/4 plus 11/4 plus 6/4 minus 8/4. So that's -11, and this is +17, so that does not work either. Oops, that was true, but it does not equal 0. All right, I'm going to try -1/3. So if I try -1/3, I'm going to get -6/27, and then I'll have plus 11/9 minus plus 3/3 is going to be 1 minus 2. All right, so now I'm going to have -2/9 plus 11 over 9. This is minus 1, so that would then be minus 9 over 9. And now I know negative 1/3 works because that equals 0. Knowing that equals 0, I can do my synthetic division. So that was negative 1/3. I've got 6, 11, negative 3, negative 2, 6, negative 2, 9. That's going to give me negative 3, negative 6, positive 2 is a 0 as we hoped. So now I've got x minus 1/3 times 6x squared minus plus 9x minus 6. Take out the 3, move it back over here. 3x minus 1 times 2x squared plus 3x minus 2, 3x minus 1 times 2x minus 1, x plus 2. If I multiply that out, I get this. So now I've got my completely factored f of x.